Okay, my dear students, now I'm about to conduct the activity which is given at the first and foremost in your textbook. Now, I have several connecting wires with me right now, and I have a dry cell with me, right? So, this is a switch and a torch bulb. So, first of all, in order to see the brightness by using a double tape, I am going to fix this thing on the stand so that you can see the brightness very well. Okay, then after that what I'm going to do is I'm going to first connect the positive terminal of the dry cell with the switch here. Then after that it runs to the one terminal of the bulb, then the next terminal to here, the second terminal of the bulb, then finally that terminal to the dry cell. So I have completed my circuit now. So when I'm going to turn on the switch, the bulb should light up. Yes, so it's lighting up. You can see there's a very less amount of brightness. Okay, so now what I'm going to do is I'm going to connect. Here I have a voltmeter. Right now, first of all, I'm going to connect the voltmeter for the two terminals given in here. So remember, when you are connecting these two terminals, the red one should goes to the positive terminal. See here, I have connected each red ones. These red terminals are the positive terminals. So I'm going to connect the red terminal with the positive terminal over here. And the black color terminal, the negative terminal with the black color terminal over here. We discussed these things in the earlier lesson also when we are discussing the features or measurements related to electricity. So now what I'm going to do is I'm going to turn on my circuit and let's see how much is the reading in voltmeter, and we're going to check the brightness of the bulb as well. Right now I'm going to turn on this switch and let's see what happens with the brightness of the bulb plus the reading of the voltmeter. So actually we have to check the voltmeter first whether our scale is correct or not, right? So now here I have prepared it so that it would measure small currents, but however you'd already know that when I'm introducing the voltmeter at the 8th lesson, I told you that there are two scales in here, the 15 volt scale and here the 3 volt scale, right? We use these two when you plug in, when you take this plug out, and if you are going to connect it with this terminal, then here the scale is from 15 volts. It's coming from 15 volts as it is mentioned 15 in here. So there is no that much of voltage in this bit of a small tri-cell, so therefore we need to adjust this one once again to 3 volts. So I have make it into the 3 volt scale here. Now let's turn on the switch and let's see, my dear children, what our result, right? So I'm going to turn on this thing now. So you can see that the bulb is glowing. Bulb has some amount of brightness, right? See, you have some amount of brightness, and let's head on to the voltmeter reading and get a reading of the voltmeter. So here don't look above, check the below reading, because that's the reading which is running through 0 to 3. So here you can observe 1, 1.1, 1.2. It's between 1.3 and 1.2, 1.3 and 1.4, right? Yes, 1.1, 2, 3. Yes, between 1.3 and 1.4 you can observe the reading, right? Between 1.3 and 1.4. So let's round off it and take it to 1.4 volts. So 1.4 volts, right? 1.4, actually it becomes 1.3 now, right? So we'll, as it is more near to 1.3, we'll take it as 1.3. Pretty much near to 1.3, my dear children. You can observe it here, pretty much near to 1.3. So we'll take the reading as 1.3. So when I'm going to connect one dry cell with the switch, with the bulb here, the voltmeter is giving out a reading of 1.3 volts. Okay, and the bulb is showing small bit of a brightness only, right? Barely visible brightness can be observed in the bulb. Right, now what I'm going to do is I'm going to remove this dry cell, this one. I'm going to remove this. So I told, but you know that we have to actually prepare 3 set of circuits. But however, the same circuit is being applied here. Only thing which is getting changed is the amount of dry cells. So my dear children, when I'm going to conduct the activity, right, separately each time, I'm going to use the same apparatus but with different number of dry cells. So now let's move on to the second setup. Now in the second setup, you have to use 2 of these, right? We have to use 2 of these. So I'm going to use 2 dry cells now. I have several prepared here with me right now. So I'm going to use now 2 of these dry cells together to get a certain reading, right? Okay, so 2 of these, let's connect and see what's going to happen. So first of all, you have to check the positive and negative terminal. So I'll show you. I have to insert it properly, otherwise there won't be any electric current flowing from the circuit. So the negative terminal here, then positive with here. Now the system is okay. So this is my negative terminal. So let's connect the negative terminal here. So I'm going to connect the negative terminal here. So I have connected it. Then the positive, I'm going to turn off the switch. Then the positive terminal to this terminal. So my children, there are 2 dry cells now. So let's turn on the switch now and let's see. Yes. So check the brightness of the bulb, children. The brightness of the bulb has got increased. It's showing a very good, I mean like it's showing a well brightness. Oh, brightness is pretty much high. When you take the previous case, right? So in the previous case, when I'm using just this one single dry cell, the amount of brightness or the intensity of the light produced by the bulb was very less. But however, when I'm using 2 of these, it's giving out a good brightness. And let's see the reading of this voltmeter. So it's near to 3 now, passing 2.5, 2.6. Yes, the value is at 2.6 now. See, it's at 2.6. So 1.3 was the previous reading. Now it has become 2.6. 2.6 volts. 1.3, 2.6. Okay, 2.6. And the brightness is pretty much high this time. Now once again, I am going to turn off my switch. Then what I am going to do is simple. What you have to do, you have to connect now 3 of these dry cells. So I have with me 3 dry cells, set of 3 dry cells right over here. Okay, so what I'm going to do is I'm going to connect these 3 to the circuit given in here right now. So positive terminal is here, positive with positive, right? Then negative with the negative terminal. So observe the brightness of the bulb. Okay, so let's turn on the switch and let's observe what's going to happen in this time. So observe the brightness, my dear children. Now the bulb is glowing at a it's emitting very high amount of light, right? Intensity of the light produced is very high. Brightness is very high. Let's go for the reading of the voltmeter. Now it has passed. See, even we can't get a reading from the 3 volt scale now. We have to change the scale to 15 volts. So I'm going to turn off this thing right now, and I'm going to take or eject this terminal, and I'm going to place it at 15 volt scale. See here, 15 volt scale is given. Now the reading is from the scale is from the top one. Okay, then let's turn on and get a reading. Once again, it's showing a good brightness, and we'll see how much is the reading now. So check the top one. Okay, here it's nearly, now here to here there are 5 units, 0 to here there are 5 units, right? So there are 1 2 3 4 5. So 1 2 3 4 5, here to 5, then 6 7 8 9 and 10. So there are 10 units from 0 to 5, means that each unit is giving half. Each unit is giving half of volts, right? As there are 10 smaller divisions. So let's count. Here to here 5. 5 means 5 times half, 2.5 volts. Then how many volts are there? 2.5, 3, 3.5, 3.5, then 3.5, 4. There are like 8 units. Count 8 units from 0 to this. There are 8 units. See, 1 2 3 4 5. Here you can observe a larger line. That's the midpoint of 0 and 5, which is 2.5. So let's count 2.5, 3, 3.5, 4. So my reading is now 4 volts. My reading is 4 volts. 4 volts. Okay. So first 1.3, second 2.6, now 4 volts. So here it's obvious to us that when I'm going to increase the number of cells, when I'm going to connect these cells in a series connection like one after the other, the voltage given out by the system or the voltage given out by the system of cells or the battery is going to increase gradually. Right, so I'm going to turn off this one right now. So let's turn off. Now what I'm going to do is I'm going to prepare all of these 3 circuits at the same time to get the necessary readings. Okay, my dear children, now I have prepared the 3 setups. Okay, so I have setup number 1 here with 3 dry cells. So to compare the brightness quite more easily, I have taken a separate holder so that it would keep rigid in our desk. Okay, so the 3 setups of bulbs with the holders, then 3 voltmeters, then here you can see a switch, here also the second switch, right? Here the second switch. Okay, then as for the third one, I have taken a different type of a switch. This is called as the plug key. So you just need to insert this plug key into this hole in order to complete the circuit. Okay, it's really simple, right? A type of a switch. So just insert this plug key into this hole here. So by that way we can complete the circuit. We'll be discussing about the plug keys under the switches part. Okay, Right, so I have prepared 3 circuits in here. First one with 3 dry cells at my left hand side. Second one with 2 dry cells. In the middle you can observe that one. This is that bulb. This is the bulb of the 3 dry cells one, and 1 dry cell. See, 1 dry cell, and the voltmeter and the bulb of that one. Okay, now let's turn on the switch and see. There is a small bit of a thing to inform, my dear children. It's that now usually when we are taking smaller voltage readings, you know that you have to take the scale here to the 3 volt thing. But the one is that now here at the third incident, or at the third instance, I have used the 15 scale, no, otherwise we can't get a reading, no? So you could observe that the reading was at about 4, right, in the third instance when we are using it alone. So by using the 3 volt scale, we can't measure 4 volts. So therefore I have arranged it to the 15 volt scale. So in each of these ones I have arranged to the 15 scale, so that the external factors would never going to change. When we are doing some kind of an experiment, we have to keep our external factors in the same stage. So I have plugged in each of these instances into the 15 scale, as I have plugged the third instance from 15. So these two are also in the 15 scale, right? So when you are getting readings, you have to check the 15 scale. Okay, right? So let's turn on each of these circuits and let's see what's going to happen. First one, then I told you that I'm going to use the plug key in the second one. So let's insert the plug key. Number 2. Then the third one. Here we go. So observe the brightness in each instances of the bulbs. Less brightness, more brightness, very good brightness, or very high brightness. So brightness is gradually increasing when you are increasing the number of cells. 1, 2 cells, 3 cells. Right, now let's go for the readings in voltmeter. Once again, check the 15 scale. So here 1, 2, 3, nearly about 3 units, right? Nearly about 3 units at the first one, right? Nearly about, starting from 0, in here you have to check. So nearly it's about 3 units. So 3 units means about 1.5 volts. Can you remember we took the reading as 1.3? So here 1.3, right? 1.5 is also correct, no problem with the 15 scale, but we'll assume that one as 1.3. Then the second one, this thing. In here you can observe the reading at 2.5 scale. 2.5 scale. So we took the reading as 2.6. However, near to that value, 2.5 can be observed exactly, right? 2.5 scale can be observed exactly. Then the third and the final one, this one, it's very closer to 5. However, 2 units are behind. So the reading in third one is 4 volts, right? 4 volts. 4 volts. So 1.5, let's take that one as 1.5. We'll round off that value as 1.5, right? So this one 1.5. After that you can observe 2.5, 1.5, 2.5, then finally 4 volts. Brightness, very less brightness. Some kind of a medium amount of brightness means that greater than this one but less than the third one. So second one has a like medium amount of a brightness in a mid range. Third one has a very good brightness over here. So these are our observations from the activity, right? So let's head on to the classroom once again and we'll write down our observations and let's see what are our conclusions about this activity, right? So remember to keep in your mind about the readings and how the bulbs are going to glow, right? So we need to complete out a table. You could remember that I told you that there is a table. So we need to complete that table. So remember about the readings. 1 point, we'll assume that this one has 1.5. Actually, we got 1.3. However, in the 15 scales showing 1.5. Here 2.5. And finally 4 volts. Right then. So let's head on to the classroom once again, children, and we'll complete out the table by using our observations. Okay, children. Now we are going to study about the parallel connection of cells. What happens in parallel connection of cells? So in the earlier case, I prepared each of the circuit in front of you. But now in these setups, I have prepared it already. Now all I need to do is turn on the switches. So, but however, I'll show you how did I connect each of these circuits given here, right? So first of all, let me separate these three so that you can observe clearly. So this is number 1. See, this is number 1. So this is the switch. One terminal is connected to the dry cell. The other terminal runs to the bulb over here. Then the second terminal of the bulb comes to the dry cell. So here one dry cell, one bulb and one switch. The second one, here I have used the plug key like in the previous case. My bulb and 2 dry cells which are parallelly connected to each other. And here the third setup, once again you can observe the switch, 3 parallelly connected dry cells, a bulb. So connecting wires in connecting each of these stuff together. Now what I'm going to do is I'm going to first of all turn on the first circuit. See, right, first circuit. Then I'm going to turn on the second circuit by inserting this plug key. Second one. Then the third one over here, number 3. Right, so when you check the brightness of each of these bulbs, I can't see a huge difference in their brightnesses. Actually, when I'm observing it very clearly, I could see that nearly their brightnesses are equal to each other. Brightness of these bulbs are nearly equal to each other. Even though when I'm going to increase the number of cells which are connected parallel to each other, the brightness of the bulbs are not getting changed at all. Brightness remains the same in each of the instances. So my dear children, we can come into conclusion finally by observing these things. So if more amount of brightness is given, like in the previous activity, we can say that more amount of current is given out from the dry cells towards the bulb. That's why it is glowing up, giving a high brightness. But in each of these instances, you could see that their brightnesses are nearly equal. So means even the 1, 2 or 3 cells, if they are connected parallelly, same amount of voltage is given to each of these bulbs, no matter the count, right? So my dear children, during a parallel connection, voltage across the bulb is not going to change at all. It remains the same at a constant value. So let's head on to the classroom and write down our observations. and the conclusions that we can take from the activity. Okay, my dear children, now let's observe what is going to happen during a series connection of bulbs. Now, in this activity, already I have prepared the three systems. This is system A, or the first system, first figure which is given, right? So we divided we categorize the three instances as figures. So this is the circuit which refers to the figure 1. This is the circuit that reflects in figure 2, and this is the circuit that reflects in figure 3. Okay, so here now you can observe this is the switch. The two terminals, one terminal runs to the bulb, and from the bulb it comes to the dry cell over here. So when I'm going to turn on the switch like this, the bulb is going to glow, right? Okay, so this is the first setup which I have prepared by using just one single dry cell. In the second instance, there is one dry cell once again. So you know that in a dry cell there is about 1.5 volts. Okay, so when you interconnect two of these bulbs, torch bulbs especially, torch bulbs are usually having about 2.8 volts. 2.8 volts, that's a usual amount. However, if you interconnect these two in a series connection, the amount of voltage that is going to draw out from one of these bulbs is going to be very high. Okay, means that all the voltage is getting absorbed for the enlightenment of the first bulb, for the illumination of the first bulb, and there won't be any voltage to travel to the second bulb. Okay, so actually what happens in a series connection is that the voltage is going to divide. I'm going to explain further things related to this division process after that. But however, you could observe in this case, when I'm going to turn on the switch, as I have used only one dry cell, the second bulb will not light up. It's because that all the voltage is being provided to the first bulb, right? So see, just showing a simple brightness, just a small bit of a light can be observed in the filament, that's it. The second one is not glowing at all. It's because the voltage given out by the dry cell is completely getting absorbed by the first one over here, by the first bulb over here, and there is no voltage to travel for the second bulb. Therefore the second bulb will not light up. So during a series connection, voltage is getting divided actually. That's why it happens. So in the third case now, I have used two different dry cells. Now in this case, right, in this case, two different dry cells means about 3 volts. So there is a remainder. After 2.8, there is a remainder. Means that both the bulbs in this case should light up. So when I'm going to turn on, see, both the bulbs are going to light up. But however, when you compare the brightness of these two bulbs with the first instance in here, there is a considerable change. I mean, like this first one is showing some amount of a high brightness, while the third instance in here, some amount of a less brightness is shown, even though when I'm going to use two dry cells, right? Somewhat low, not that much low, but however, the brightness of this one is somewhat higher than these two. It's because now the voltage given is not divided in this system, as there is only one. So the voltage given across these two is getting divided into two different parts. So these two, when it is getting divided, it's like, right, you know that these things are providing about 3 volts, but however, when passing through the circuit and when we consider the other factors like resistance, some amount is getting lost. So therefore, right, the brightness of these two is somewhat lesser, somewhat not that much lesser, but somewhat lesser than the first one. So now let's turn on the third one so that you can observe a good reading. Actually now here the second one is actually not working at all, but the first one is showing just a simple amount of a brightness, right? The filament of the bulb is has some amount of a brightness, that's it, right? These two are showing somewhat good brightness. However, the brightest one is this thing. You can observe it very clearly when you are looking at the bulbs. So my dear children, the observation is when you are using one single bulb, right, with one single dry cell, it carries a somewhat greater brightness. In the second one, very less bright, right, very less bright. Let's assume that this is also going to light up. If so, very less amount of brightness is observed in the second one. In the third figure, brightness is greater than the second instance in these two, but less than the first one, right? So during a series connection, what happens here is that the current or the voltage across each of these items is going to divide and travel. Okay, if there are two units, then the whole voltage is getting divided into two equal parts. However, those things should be identical. So we'll be clarifying these things furthermore when we are discussing about the lesson. So the observations and the conclusions of this activity are really simple, right? So let's head on to the classroom once again and we'll write down our observations and our conclusions from the series connection of bulbs. Okay, my dear children. Now in the earlier activity we discussed about the series connection of bulbs. Now in this activity we'll be observing or we'll be investigating what happens, right? What will happen when you connect bulbs in a parallel connection. Okay. So first of all, I have prepared the three circuits according to the diagrams which given. Now the first circuit is this. This is the first circuit, not this one, but here you can observe the first circuit. One dry cell, a switch, and you know this is our bulb and the holder. So when I'm going to turn on this switch, you can see the bulb is going to light up. Okay. Then after that, the second system, once again you can observe the switch, just a one dry cell and two bulbs which are parallel connected to each other. How can you say that these two are parallel connected? It's simple. See, red terminal, red terminal. Usually you know that the red terminal is positive. Two positive terminals are interconnected by this wire. See, two negative terminals are also interconnected by this wire. See, and finally these two wires run towards the dry cell through this switch over here. So it's really a simple setup. However, identify the connection between these two bulbs. So that connection is a parallel connection, as the two negatives are interconnected each other with the two positives like this, and they run towards the system over here. Alright then, so this is the parallel connection of second system or the second circuit. Now let's turn on the switch and let's observe what will going to happen. Now here you can see, let's open the first one as well, keep in the same way. Now here you can see, even though in the earlier activity, when the two bulbs are series connected, just one bulb give out a very small bit of a brightness. However, in this case, both the bulbs are showing equal amount of a brightness. Both the bulbs are glowing, but still it's not giving out that much of a brightness. It's because we used only one cell over here. And if you check with the other one, here with this bulb, brightness of these bulbs are also similar. There is no that much change in it. So if you check the system, if you check the brightness is somewhat similar in this one and this one. Actually, there is a small bit of a change. It's because of the resistance of each of these instruments which are getting connected. So you know that there is a obstacle which is given by each of conductors when they are connecting with a certain circuit system, right? So there is some amount of resistance in each of these instruments. So you know that in the earlier lesson we discussed that when you are connecting several components like this, even the switches are also having some amount of a resistance. Each and every conductor has some amount of resistance. So when increasing the number of conductors in a circuit, some amount of resistance is provided. So upon that, there might be a very simple loss of energy, electrical energy. However, my dear children, right, if you compare the brightness, nearly it is getting equal in these two instances. Now let's turn on the next one. Here we have two dry cells, right? We have two dry cells with three parallel connected bulbs. Now I am going to turn on this switch by using this one. See, all three bulbs are glowing very well. If you compare the brightness of these ones, brightness is very high. When you compare it with the other ones, brightness is very high. See, brightness is very high. So here we can say that when you are connecting these in a parallel connection, there is no division in the voltage like in the earlier case. The voltage is getting directly supplied to all of these bulbs at a similar rate. That's why they are showing equal amounts of brightness. Here also the same. They are showing equal amount of a brightness, right? And the other thing is that when you interconnect these in a parallel connection, right? When you interconnect these in a parallel connection, we can use these systems, right? We can use these systems in order to, like, we can operate these systems, like you can operate these systems for a longer time period, right? So that's the specialty in parallel connections. So if you take the parallel connections, usually in our household electricity, they also have parallel connections in our circuits. So this is the parallel connection of bulbs then. So during a parallel connection, always remember voltage is not getting divided, but the voltage is being provided to each of the instrument. Here it's bulbs, right? Each of the bulb in an equal amount. So the brightness of the bulbs would be the same. There is no difference at all. When you are increasing the voltage by providing two or more dry cells, we can observe the brightness of the bulbs are also getting increased. However, if you compare the brightness of bulbs, they have equal amounts. Okay, so this is the parallel connection of bulb systems. Okay, so in a parallel system, remember my dear children, each and every component has the same amount of voltage across it. So let's head on to the classroom and we'll write down our observations and conclusions from this activity. Okay, my dear children. Now in this activity, we'll be lighting up several LED bulbs, right? So I have several LED bulbs here with me, which attached to the desk. So all of these bulbs are these units actually, right? This unit and this unit are series connected to each other, right? So these two green bulbs are series connected with these items and these items. So these are red and blue, right? So these two are series connected. These two are parallel. When you take these three levels are parallel connected. These are series connected to each other. Okay, you know the connection method, right? So here one terminal starts with and it's go through the other one and comes around here. So it's a series connection. Now in this one also series, this one also series. But when you take these are parallel connections, right? Parallel connections. Now by using these clips, I'm going to connect it with the switch, right? I'll connect this one to the terminal over here, then this one with the switch, this one to the dry cell unit and to here. So actually I have used a switch here in order to turn on and off the apparatus or the circuit given in here. Actually it is going to act as a simple bit of a panel, Vesak panel, right? You know that panels are in panels can be observed in our Vesak season, no? So it's like a panel, a small bit of a one, right? Not that much of a large one, but a small bit of a one. Now let's see what will happen if I'm going to turn on the bulbs. So you can see that there are different colors, right? So it's very colorful. You can see red bulbs, then the green bulbs, then the blue bulbs. So by turn on and off these things like this, we can like create a small bit of a panel, right? Like this. Okay. So there are different types of circuits which this switching on and off process is going to happen automatically. So by that way, actually the larger panels are created in our Vesak seasons. So up to now we have created a small bit of a Vesak panel by using several LEDs which are connected like this way and by using a simple switch like this. See, so here by using different types of LEDs, right, we can light up or we can illuminate, right, the different conditions, or we can illuminate these LED bulbs in different occasions in order to light up and decorate our occasions, right? Simple example for such kind of an occasion is the Vesak season. To enlight or to light up our houses, right, we use these instruments. Right then children, so let's head on to the classroom once again and we'll discuss what are the other things contained in our lesson. Right. So once again you can observe from here to there. See, this is the normal switch that we use, right? Normal switches. There is a handle. You can turn the handle to here and there. A simple handle switch with a single pole. This is a handle switch with a dipole. Dipole means we can disconnect two wires at the same time, like this. Two wires at the same time. Same handle switch but a dipole handle switch. This is called, this one is the plug. This instrument is the plug key switch. So this is the plug. So you have to insert this plug into the hole over here. By that way the current flow will be continuous. Right. So my dear children, the final one is the tap key. So you have to tap on the hammer in here. by that way the circuit is getting completed from here to here. The current is flowing from here to here very easily when you tap on these things. When you are tapping on the hammer here, the metal plate or the connector is going to connect with the handle over here. Then by that way the electricity is going to flow from that end to this end. So these are the different types of key switches or the switches that we can observe in our laboratory. So most of these switches are being used at day-to-day instances as well. Okay, right. So once again, let's head on to the classroom and we'll observe what are the other things contained in our lesson. Then I have another type of a switch over here. This is called the tap key. Why does it called as the tap key? I'll show you by connecting these crocodile clips and by operating the switch. Why it is called as the tap key. Okay. So I have connected my switch to here. Now, there is a hammer like thing in here. What you have to do, you have to tap on this. Upon tapping, you can see that the bulb is going to work. So this is also really simple. What you have here is a metallic plate running from here to there. It's been connected with this terminal over here, and this terminal is being connected over here with the other terminal. So we have to connect it for these two terminals. You can check. You can remove this thing, the screw, and if you want, you can connect with the wires like this, like in the earlier case I have shown you. So if you don't have wires, you can just simply keep the crocodile clips like this. Now what you have to do to turn on the circuit, you have to tap on this hammer. See? So this instrument or this switch is called the tap key. Okay, tap key. So this is how the tap key is going to work. So my dear children, within this activity we'll be discussing how to connect these permanent resistors to a circuit. And once again, upon connecting these permanent resistors, what will happen to the brightness of this bulb and what would be our reading in this ammeter? Now it's been said that a milliammeter is the convenient one, but however we can do this activity by using the ammeter as well, right? So here I have the ammeter. You know that in an ammeter also there are two scales, 3 amperes one and 0.6 amperes one. So here I have plugged this red key to 0.6, means that I have to take the lower scale starting from here to there. So 0.2, 0.4, 0.6. Check only with the lower scale, don't check the top one. Okay, so I have connected the ammeter in a series connection. First of all, you know that ammeter should be connected in a series connection. So ammeter series connected with the bulb. Then after that it comes to here. Now I am going to connect this bulb to here onto the switch. Then this one to here. Okay. Now what I'm going to do is, now I have two resistors with me, permanent resistors, but however the circuit is now completed, I'm not going to connect those things right now. Right, so what I'm going to do is I'm going to turn on the switch right now without connecting these things, and to get a reading related to the brightness of the bulb and plus with the ammeter reading. So let's connect and see. So you can see that the bulb is giving out a good brightness, right? The bulb is illuminating very well and it is giving a good brightness. Let's see the reading of the ammeter. 0.2 and there is some bit of a change as well. Now here to here 0.4, no? So here to here 0.4 means that there are 2 units. So altogether there are 10 divisions. So when you divide 2 by 10, right, or 0.2 by 10, you have to divide 0.2 by 10. It's about 0.02, okay, 0.02. So here 0.2, then 0.02, 0.2 is in here. Now you know that the middle is 0.3 then. So if the middle one is 0.3, how many readings or how many smaller blocks are there? 1, 2, 3. It's at 3, right? It's at 3. So it's nearly 0.3 but somewhat less. So we can say that 1, 2, 3, 4, 5 means that 0.26, because at here at the middle it's 0.3. So 0.26 will say that that one is 0.25 of amperes. 0.25 nearly. So here when it is come to the middle, at here at the fifth marker it becomes 0.3. So at the middle we can say that it is 0.25. Okay. So 0.25 is my reading. 0.25 is the reading. 0.25 amperes. Remember 0.25 amperes. If you are going to use that thing in milliampere thing, right, or the by using a millimeter, if I'm going to conduct this activity, my reading would be 250 milliamperes. So however I have used the ammeter thing. So in the ammeter the reading is giving out as 0.25 of amperes. Okay, 0.25 of amperes. This is my reading from the ammeter. Right. So there are no any resistors connected with this circuit. Okay. Now let's see what will happen if I'm going to connect a resistor. Now I have with me a 5 ohm resistor. So here ohms value 5 ohm resistor. I have a 5 ohm resistor. Your book says that we need to connect a 2 ohm resistor, but however I'm going to connect a 10 ohm resistor in the second instance, 5 and 10. Okay, right. So let's see, by connecting these resistors to our circuit, what will happen to the brightness plus what will happen to the reading of the ammeter. So first of all, I'll take this 5 ohm resistor, this one. So I'm going to take 5 ohm resistor and I'm going to disconnect the switch from here. I'll use a different crocodile clip. So specialty in resistors is that there are no distinct terminals. I mean, like if you take a dry cell, there are 2 distinct terminals, positive one and the negative one. So like in the bulbs, like in the torch bulbs, you know that in a torch bulb we can connect even by changing the 2 terminals, the metallic cover and the tip. No matter how the way of connection, the bulb is going to light up. In the same way, these ones also having 2 terminals. However, there is no distinct positive or negative terminals in it. So you can connect these 2 terminals as either ways, no matter at all. So what I'm going to do is I'm going to connect this thing to the circuit first and the second. Right, and now with the switch. Okay, now I have connected 5 ohm resistor to my circuit. Now let's turn on the switch and we'll see what's going to happen. So in the earlier case, I think you could observe that the brightness is somewhat more. Okay. But in this time, the brightness has got reduced. Brightness has dramatically reduced. So if you want to check the brightness in the earlier case, I can do you a trick like this. I'm going to eject this one and interconnect with this thing. See? Can you see that? How much is the brightness with this one? And check with this one. See? And once again check the reading of the ammeter as well. This is the original without connecting the, right? This is the original without connecting the resistor. See? 0.25. Near value is 0.25. What happens when you connect the resistor? 0.25 drops to 0.2. That's why the brightness of the bulb is getting reduced. So now it's 0.2, brightness is less. Earlier 0.25, brightness is somewhat more. Okay, with the 5 ohm resistor. So remember, my dear children, reading 0.2, brightness less, 5 ohm resistor, not the 2 ohm one. Okay, we used the 5 ohm resistor. Okay, so I'm going to remove the 5 ohm resistor now. So let's keep it in here. Now it's time for the 10 ohm resistor. 10 ohm resistor. So we'll connect and see what will happen. Okay, so let's turn on the switch. Now you can see that the current is dramatically reduced. Actually, there is no brightness in the bulb. Small bit of a brightness can be observed. Actually, that's on the filament, just like a blip. That's it. Okay. Let's check the ammeter reading. Now the ammeter reading has even been dropped below 0.2. So let's count how much is the number of units. Now over there is between here and here 0 to 0.2, there is a middle marker over here 0.1, right? 0.1, then 0.12, 0.14, 16, 18. So like it's like 1 unit. Yes, 0.18 is the answer. 0.18, 0.18, not 18, right? It's 16. There are 8 units now. 0 here for 0.1, then 1, 2, 3. Yes, 3 units. 3 units means 0.16, right? So 0.16, 0.18, then 2, 0.2. So 0.16 is our reading from the ammeter. 0.16, brightness is very less. Brightness is very less. Actually, there is only a blip. So blip in the bulb, 0.16 as the reading, right? So once again, I'm going to eject this thing and I'm going to show you what will happen if I'm not going to connect any of these resistors. I mean in the same circuit which we used earlier. See, a good brightness and the ammeter reading runs to 0.25. Good brightness reading runs to 0.25. See, after connecting the resistor, ammeter reading runs to 0.16. Brightness is very less. So these are permanent resistors, my dear children. Permanent resistors can change the current in a circuit. Actually, changing means decrease the current in a circuit. So when we are increasing the resistance. By that way, we change the current. So this is the first type of current controlling devices, fixed resistors or permanent resistors. Right, so let's head on to the classroom once again and we'll write down our observations and conclusions from the activity. Okay, my dear children, now these are several resistors which I have with me right now. So these resistors are specially referred as fixed resistors or permanent resistors because the value of the resistance is not getting changed in these items. So here in ohms, right, in ohms the value is being printed. Now here you can see that here it's mentioned 5, means that this resistor is 5 ohms. See, 5 ohms, 5 ohms. Okay, and this one I have with me is a 10 ohm resistor, right, 10 ohm resistor. Then I have another several permanent resistors with me. Now these resistors have some colors on their body. These resistors have some colors on their body. These colors are reflecting the amount or the value, right, the amount or the value of the resistance, right. So I have with me right now here, right, so these things are referred as the permanent resistors, my dear children. So in each of these permanent resistors, their color codes are different to each other. Their colors are different. Now here, in here, this resistor, there are 2 red color ones. And here there is a black color one. And here there is a brownish color one. And here there is a brownish color one and once again a silver color one. Like that way, there are different colors in their body. Actually, if you count the number of colors or color bars, there are 4 color bars. These 4 color bars are used to calculate the value of the fixed value resistors. Now in these types of resistors, the value is being printed now. See, in here the value is printed in ohms. So here it's 5 ohms. It's 5 ohms. It's been printed. But in these cases, if you take these cases or these smaller resistors, in here there is no such value. So value is getting reflected by their color code. So when you go to like grade 10, you will get to know how to calculate the value of a fixed value resistor or the resistance of a fixed value resistor by using ohms, by using these color code systems. So these are the ones which are referred as, my dear children, permanent resistors, right? So we use resistors, these permanent resistors, in order to reduce the current flow in a circuit, right? So let's head on to the classroom once again to discuss further things related with the lesson. Okay, my dear children, now within this activity we'll be identifying how does a variable resistor is going to work. So I have with me this instrument. Now this instrument is called the rheostat, right? This is a variable resistor, right? The variable resistor which is referred as the rheostat. So in a rheostat, a specialty here is that I can change this handle here and there. By that way I can change the resistance of it. So when I'm going to change the resistance, I'm going to change the electric current. So we'll be learning about the rheostat and how to connect these rheostat to a circuit. And the way the rheostat is going to change the electric current in a circuit. All of these stuff are being discussed later with the lesson. So just now we'll be identifying the action of a variable resistor. So in order to identify the action of a variable resistor, I have a milliammeter with me. So here you can measure up to 100 milliammeters. Now I'm going to connect my rheostat with this dry cell towards the switch which goes around here and for the milliammeter to check the current which is flowing through the milliammeter when I'm going to change the position of the handle. So let's connect these instruments together. So these are the two terminals, or else if you want you can get this terminal as well. Both of these two terminals are same. If you want you can get this terminal and this terminal, or else this terminal and that terminal over here. Okay, these are the two terminals mainly that we are going to use. Right, so let's connect the instruments together. So I'm going to connect first this milliammeter to the circuit. Then after that, this one to here. Right. So in this rheostat, my dear children, these two terminals are the ones which are having same terminals, right? So when you are connecting this rheostat to a circuit, we have to connect this one with this one. This is the change in one. These two are the same ones. Okay. Right. So now what you have to do, we need to turn on the switch. So I have connected, see, the dry cell, positive terminal runs through here and comes to the rheostat, and it goes through here, goes to the switch, comes back to the milliammeter, then through the milliammeter to the negative terminal. That's how the electricity is going to flow within this circuit. So now what I'm going to do is, I'm going to turn on my switch. So I have turned on the switch. See, the reading is now at the maximum position, somewhat below the 100 milliampere range. Okay, so here you don't need to take actual, like exact readings when I'm going to turn this handle here and there. Now I have the handle of the rheostat in here, okay, at this column near to this one. So it's far away from the red terminal over here. This is the other terminal. It's pretty much near to this terminal. Now I'm going to take this towards that red color end and observe what's going to happen with the reading. When I'm going to take the handle gradually towards that direction, you could observe that the reading in millimeter also drops down. Means that the current which is going to flow through the system or through the circuit is gradually getting decreased. Right? See, now it is at a minimum level. It is at a very minimum level now. It's about 25 milliamperes. See, once again when I'm going to pull this handle towards that direction, right, you can see that the scale is now greater than 100 milliamperes. If you want to adjust this thing to 80 milliamperes, by looking at this, we just need to take this one to this direction gradually. So by that way up to 80, like this we can take it up to 80. If you want to take it to 40, then once again do the same thing. Turn to the other side like this. Right, see, exactly 40. If you want to make it to 60, take to the opposite direction, see. Exactly 60. So by using this instrument, the variable resistor, here we use the rheostat. Okay, we can change the current in a circuit according to a desired value. Whatever the value we want, we can change it, but it should be within a certain range. Now here it's given that we can change up to a certain level. Now I'm going to show you, when I'm going to discuss about the further things related to the rheostat, I'm going to show you that there is a certain scale, right? Like we can't get like 250 milliamperes from this thing, right? We can't get like 3 volts, we can't get like 3 amperes of a current from this thing, right? We can't reduce the current up to 0 like this from this thing, right? So there is a certain range for each and every variable resistor. There is a certain range. Most of the times that range is being printed on the it's being printed on the surface most of the times, right? So if you are going to use a volume controller instead of a rheostat, right, by turning the lever we can change the current in the circuit. So this is the action of a variable resistor. So in a variable resistor we can vary the current in a circuit and we can adjust the current into a desired value. So this is the action of a variable resistor, my dear children. So let's head on to the classroom once again and we'll identify what are the types of variable resistors, and once again I have to come to here to observe about the rheostat. We'll be discussing about the rheostat furthermore when we are going to classroom once again. So let's head on to the classroom, my dear children, and let's discuss what are the further things related with the lesson. So my dear children, now I have in my hand a rheostat. So this is the one, or this is a variable resistor. So what do you mean by a variable resistor is that we can change the amount of resistance given out by this instrument. So when changing the resistance value, you know that the value of the current is also going to change. So here it's been printed, you can see at the top of the instrument, it's saying 1 to 8 amps. It's 1 to 8. Amps means amperes. 1 to 8 amperes. So when I'm going to turn this metal bar, right, this lever on the metal bar, when I'm going to turn to here and there, I can change the value of the resistance. So the resistance is getting changed. When the resistance is getting changed, the current is also going to change. So I can change from 1 ampere to 8 ampere of current. Okay, 1 to 8. And if you check the value of the resistance, it's 80 ohms. Starting from 1 to 80, right? Maximum we can give out to 80 ohms. Right then. So let's observe the outer structure first. So there is a handle. Now along this handle there is a lever. So I can push this lever along the handle here and there like this. So to which place do I need to connect my terminals? So that depends. There are actually 3 terminals, 1, 2 and 3. Right, 1, 2 and 3, there are 3 terminals. Usually as for our convenience we use 2 of these 3 terminals, 1, 2 and 3, 2 of these 3 terminals as for our convenience. Usually we can connect for these 2, see, by removing these and fixing wires, you can connect for these 2. Plus if you want, you can connect it with this one and this one as well. This one and this one over here, right? So this is how the rheostat is going to work. Now when I'm going to turn this thing here and there is a coil which is wrapped on the base. There is a coil which is wrapped on the base of this rheostat. So when I'm going to turn this one here and there, what will happen here is length of the coil is getting increased or decreased. So you know that length of the conductor is paying a, or it's giving out a, or it's going to impact directly on the resistance. So therefore, when I'm going to change or when I'm going to increase or decrease the length of this coil by turning this handle here and there, I can change the resistance in the circuit. When changing the resistance, I can change the current flow in the circuit. Okay, my dear children, so this is the instrument which is referred as the rheostat, right? And the components contained within the rheostat. So in order to change the current flow or the resistance in the circuit, we are going to change the length of the conductor in this wrapped coil, right? By that way, we are changing the resistance or the current in the circuit, right? So let's head on to the classroom once again and we'll discuss what are the other things contained within the lesson. Okay, my dear children, now we are going to connect a rheostat to a circuit. And by changing this terminal or by changing this lever, I'm going to observe the brightness of the bulb in different instances according to different readings of the ammeter. So let's see how to connect our rheostat to this circuit. Now I have used several dry cells here in order to provide at least about 400 milliamperes of a current, right? In order to provide a 400 milliamperes of a current, at least I need these much of dry cells, right? So I have a bulb with me here and a switch. So first of all, the positive terminal of the positive terminal, this red color terminal, I'm going to connect it with this terminal over here. So in a rheostat, children, always these two terminals are similar. So when you're connecting, you have to connect it with this terminal or this terminal, definitely with this terminal which has the handle. Okay, so I have connected the positive terminal to here. Then for this handle, I need to connect the other positive terminal like this. Then this is the dry cell. Right, so this is the dry cell set, the bulb. So I have connected the dry cell negative terminal of the dry cell to the negative terminal of the ammeter, and ammeter is connected with the 0.6 scale. You can see it, 0.6 scale. Then it runs through the switch over here, and through the switch comes back to the bulb, then from the bulb to the rheostat to the positive terminal. Right, my dear children, now let's turn on the switch and we'll see what's going to happen within the circuit. So I'm going to turn on the switch right now. Right, so bulb is lighting up, it has a good brightness. Let's see how much is the volt ammeter reading. So earlier, now it was on here at 0, here 0.2, and now here you can observe between 0.2 and between 0.4 the needle or the reading is being placed between 0.2 and 0.4. That means the value is 0.3 now. So actually we can't take up to 500 milliamperes of a current. So I can show it to you. See, maximum is this. This is the maximum amount. When I'm going to turn it to over there, it's going to reduce. See, this is the minimum, this is the maximum. So here the maximum value, let's say in here it's 0.4, no, so 2 units behind. 2 units behind means the value is, so I told you in the earlier case, this one has a half or else 0.25 of amperes. 0.25 of amperes is equal to one particular smaller division, 0.25. So let's count. Here to here 0.3, then 0.2, 0.25 once again. Then we can get a reading up to like here 0.3, 0.32, 34, 36, 38. Okay, now it's about 0.3234. It's about 0.35. 0.35 now means 350 milliamperes. 350 milliamperes. We'll round off it and take it as 350 milliamperes. So 350 milliamperes, my dear children. Under 350 milliamperes, bulb is showing a very well brightness. Right? Brightness of the bulb is very high, 350 milliamperes. Okay, how do I took my answer as 0.35 or 350? Because in here you can observe 0.2, here you can observe 0.4. At the middle it should be 0.3. So 0.2 to 0.4 there are 10 divisions, 10 smaller divisions. 0.2 to 0.4 there are 10 smaller divisions. So when you divide the gap between these two area, 0.2 to 0.4, the gap is 0.2. So when you divide that one by 10, answer is 0.02. So each of these scales are going to show 0.02. Okay, so here 0.1, then when increase by 0.02, 0.12, 0.14, 0.16, 0.18, then finally 0.2. Okay, so my value is now at 2 units, just 2 units, right? Not 3, just 2 units. Actually it is between 2 and 3, right? So in order to get a good reading, what I'm going to do here is I'm going to change the lever somewhat to the other side and I'm going to arrange the current up to 0.2. Right, now it's 0.2. The reading is at 0.2. Check the brightness. Brightness is very less. So 0.2 very less bright. 0.2 very less bright. Then once again I am going to turn to the other side and turn to the other side. I took for this side, no, now I am going to take it to the other side. So when I am going to take it, the lever to the other side gradually changed. So what I am going to do is I am going to take it up to 300 milliamperes or 0.3 at the very middle of 0.2 and 4. Right now it's 300. Check the brightness, my dear children. Brightness is very high. Brightness is very high. 300 milliamperes brightness, very high. Once again I am going to now take the lever to 0.2. See, 0.2. What happens with the brightness? Brightness has got gradually reduced. Brightness gradually reduced. Reading is now at 0.2. Reading is now at 0.2. Brightness is very less. In the earlier case, brightness is more. 0.3 was the reading, ammeter reading. Now I am going to take even further, like up to 100 milliamperes, exactly at the middle of 0.1 and exactly at the middle of 0 and 0.2. Right, here we go then. What happens with the bulb? There is no illumination in the bulb under the 100 milliampere thing. There is no illumination at all at 100 milliamperes, right? So at 100 milliamperes, the bulb will not light up. Once again, I am going to change up to 200 milliamperes. 200 milliamperes. Check the brightness, my dear children. It's going to increase gradually. 200 milliamperes. So 200 milliamperes. Here we go then. 200 milliamperes. Check the brightness. See, it's showing a good brightness now. Earlier, under 100 milliamperes, there was no light at all. Bulb is not going to bright. Bulb is not going to glow. It's not emitting light at all under 100 milliamperes. 100 milliamperes of current is not enough for the bulb to light up. Then this is 200 milliamperes showing some amount of a brightness. Then we'll go for the 300 milliampere thing exactly at the middle of 0.2 and 0.4. Here we go then. 0.3 brightness is very high now. So this is how can you change the current in a circuit. This instrument is the rheostat. By changing the lever position here and there, we can change the current. Here the factor which is actually getting changed is the resistance. So by changing the resistance, we can change the current. So like this way, from a minimum value to a maximum value, we can change the current in a circuit. So this is how a rheostat is going to work, my dear children. Right. So let's head on to the classroom once again and we'll write down our observations and conclusions from the activity. Okay, my dear children. Now within this activity, we'll be observing how to connect an LDR to a circuit. And during the connection, we'll be observing how to change the resistance in order to change the current flow in a circuit by using this LDR. So this is the instrument which is referred as the LDR. It's a very small tiny device which can be used to control current or control resistance in a circuit by changing the amount of light obtained by the LDR. Okay, light dependent resistor. So first of all, I have galvanometer with me. You know that galvanometer is a type of an ammeter, right? Means that we can measure very small amounts of current. So I'm going to connect the two terminals of the LDR like this. LDR, the two terminals of the LDR like this. Okay. LDR now is facing towards the light. So it's receiving plenty of light right now. Then I have an LED with me. Instead of a torch bulb, I used LED because as there are several components around here, like this is there is a galvanometer, switches, then connecting wires, crocodile clips, like that way there are several things now. So therefore, if we are going to use a torch bulb, then the power which is given by these two dry cells will not be enough to light up. So thereby I am going to use an LED in this process. So let's connect the LED. Right, so I have connected the system right now. Let's see how it is going to work. The positive terminal comes from here, goes to the switch, goes to the other terminal of the switch, come towards the LDR, come towards it's going to come towards the galvanometer, then through the bulb towards the negative terminal. So this is the flow of electrical charges. Now let's turn on the switch and we'll observe what's going to happen with the brightness of the LED plus with the reading of the galvanometer. Right. So as you can see, when I'm going to turn on the switch. The bulb is glowing right now. LED, the bulb showing a good brightness right now. The reading has reached to the maximum level and it's like greater than 30 milliamperes, greater than 30 milliamperes, and it is showing a good brightness at the LED as well, right? At the LED, good brightness, and it's going over 30. So the LDR is receiving plenty of light. Now what I'm going to do is I'm going to cover up the surface. See, current flowing through the circuit is going to drop down like up to 10 milliamperes, and the brightness of the bulb, see, the brightness of the bulb has got reduced. I'm going to remove my hand right now. See, brightness has got increased once again. Can you see that? It's pretty simple. If I'm going to cover the surface entirely like this, it's going to drop even down and there is very less amount of light. Once again, I'm going to open it. You can observe a good amount of light which is getting emitted. So here we can say that according to the amount of light which is received by the LDR, right, like this, the amount of current flowing through the circuit is also going to change. When I'm going to cover it down, you can see that, see, when I'm going to cover it down, you can see that the current flowing through the circuit is decreased gradually. It's because that when dark or when light intensity of the light is getting reduced around the environment, when less amount of light energy is received by the LDR, resistance is high. If there is high resistance, current flow is low. So that's why when I'm covering the LDR, right, like this, less amount of light in the LED and the reading is nearly now 0. When I'm going to open it, plenty of light is being obtained as the surface is exposed to the outer environment. So in that case, bulb is showing a good brightness, plus the reading of the ammeter or the galvanometer in here, it reaches to a maximum level. So once again, you can see that covering getting reduced, exposing getting increased. When I'm going to cover it, once again it is getting reduced. When I'm going to expose, it's going to increase. So this is the action of an LDR, my dear children. LDR can be used to change the current in a circuit by changing the resistance. So according to the amount of light received by the surface of the LDR or the light dependent resistor, the resistance is going to change. If we expose the surface to outer light very well, the resistance is very low and plenty of current is going to flow like this. If I am going to cover the surface like this, dark or the light intensity of light received by the LDR is very less. In that case, the resistance would get increased. If the resistance is getting increased, what will happen in this situation is the current is also going to reduce. Higher the resistance, lesser the current. So therefore, what will happen? The current will get reduced, reading comes back, and the brightness also is getting reduced. So this is how an LDR is going to work. So let's head on back to the classroom and write down our observations and conclusions from the activity. Right, my dear children, now I have with me a bout. So this is referred as the bout. Now I have connected this thing to electricity, right? Below it has a plug. So I have connected it to electricity so that it would heat up. So this would heat up in order to produce heat energy, and I have a small bit of a circuit with me. So these terminals over here are the ones which are referred as lead. So these are lead. So we use lead to fix these instruments to a circuit. So it would firmly fit on lead. Okay. So to melt lead, we can use the bath in here. So now I have melted some, right? I have melted some lead. See, here you can observe I can melt it by using the bath. See, it's going to melt down. So I'm going to show you how to connect this wire into my circuit in here. So what I'm going to do here is I'm going to melt this thing down by keeping the bath. So like this. So if you have lead, then the action would be much easier. But I can show it to you. Most of the times we'll be using fresh new lead. So like that way, see, it's been fixed to the circuit right now. See, you have to break it down and take it out, right? So once again, I can show it to you. See, I'm going to take this one, I'm going to melt this and keep it on the surface. Right, my dear children. Now, when you are using these instruments, be very careful because, see, so like that I can heat up. So like this is connecting the wire, no? So we can use this bath in order to remove objects as well. So there is an LED here. I'm going to remove this LED by keeping it like this. And you just need to keep it like that way. And after the lead is going to melt up, pull it like this. See? So if you want to fix it back, what you have to do? Insert it like this and get some lead and keep two dots like these into the terminal. So you can remove instruments by using the bath, plus you can solder instruments or electrical components to a circuit like this, right? So this is the soldering equipment which is referred as the electric bath, right? Then so let's head on to the classroom once again and we'll observe what are the other things contained within our lesson. Okay, my dear children, now within this activity we'll be observing the heating effect of electric current. So already I told you that when I was starting the lesson, by providing electricity we can heat up a certain instrument, right? So I have a bulb with me, several dry cells and a switch. So what I'm going to do is I'm going to turn on this bulb by connecting it with several dry cells like this. Here, positive terminal and the switch. So I'm going to lift the handle, connect it like this. First of all, now I'm going to check the initial temperature. So my dear children, when I'm going to touch this thing, I can't feel any temperature. I mean, like it's in the room temperature. It's not hot, right? So there is no temperature. We'll assume that it is under the room temperature, 27 degrees of Celsius, right? So it's not hot at all. Right, now what I'm going to do is I'm going to turn on the switch and let's see what's going to happen after some while. So let's turn on. So let's keep it for some while. So when I'm going to touch this thing right now, I can feel some amount of a warmth, right? So I can feel the warmth in the bulb. Actually, it's getting very hot, right? So if you keep your fingers like this for a longer time, definitely it's going to be very hot. So what's the result of this experiment then? Upon providing electricity to a instrument, we can say that, there is a heating effect, or the instruments are going to heat up upon providing electricity. Now, at your houses, you might have experience in changing electric bulbs. So if they are operated for a long time period, upon removing, you can feel a warmth. It's because of the heating effect given out by the electric current. So any instrument which is operated by electricity is going to heat up. So electric current has an ability to generate heat energy when electrical instruments or appliances are going to operate. So that's why I can feel a warmth when I'm going to touch the bulb. So my dear children, if you have been asked to remove a bulb at your house, don't touch it like this, okay? Definitely it will hurt you if it is being operated for several hours. Use a piece of cloth and then remove the bulb, okay? So this is how the heating effect is going to work. Not the bulbs, but if you take any kind of an instrument, even televisions, radio, any kind of an instrument which is operated from electricity, those instruments are going to heat up upon providing electricity. So this is the heating effect related to the electricity, right? So my dear children, let's head on to the classroom once again. Let's observe what are the other things contained in our lesson. Okay, my dear children. Now, in order to identify the heating effect quite well, here I have prepared a special kind of a setup. Within this setup, there are 3 iron nails, 1, 2 and 3. And for the first 2 iron nails, for the first one and for the second one, I have connected a nichrome coil. So this is a nichrome coil, nichrome string. You know that nichrome has very high resistance, right? In the earlier chapter, lesson 8, right, we studied about the nichrome, that it has very high amount of resistance. And this one, which runs through the second iron nail and the third iron nail over here, is a copper string, right? Copper string. So these two are being connected here to a 9-volt dry cell, which runs through a switch and which comes to the nichrome coil once again to here. So the circuit is getting completed like this. From positive terminal through the switch, through the other terminal, through the nichrome string, towards the copper coil, towards the other nail, comes back to the negative terminal. So now what I'm going to do is I'm going to turn on the switch, and by touching each of these strings, I'm going to check the temperature, right? So we have to turn it on and keep it for a while. It's because that here we are studying about the heating effect now. So in order to identify the heating effect, we have to keep it for some time. So let's wait for some while and we'll observe what has happened with the temperature. So initially there was no temperature. You could see that I was touching it, right? So let's see what happens after some time. So okay, my dear children, now let's touch and see. So it has a good temperature. Even I can't touch it with my bare arms. Nichrome coil has a very good temperature. But the copper thing is, it's still not like I can touch it my bare arms without any harm. There is no problem in touching this thing, but this thing is really hot. So it's actually really hot if you are going to touch this thing, right? You can feel the warmth very well, right? So it's really hot. Even my fingers are getting, right, heated up, or fingers are getting burned when I'm going to touch this thing. So this is very hot, but still there is nothing in this one. But in here, you can observe it's very hot. Okay. So within this activity, we can see that when you compare the heating effect of copper and nichrome, right? This is nichrome, right? So it's very hot right now, but copper, it's not. So I'll turn off the, right? Still it is hot. Now I can touch up to a certain extent. And now it's been weared off. Once again, when I'm going to connect the circuit, it is getting heated up very quickly. Yes, but however, the copper, there is nothing. So by conducting this activity, we can say that, my dear children, nichrome is a type of a metal which is getting heated up very quickly. It's because of the resistance bear by the nichrome. In nichrome, there is high amount of resistance. So if there is high amount of resistance, upon flowing electric current, it's going to heat up very quickly, as there is more obstacle against the current flow. So the particles are getting collided, or these electrical charges are getting collided with the surface of the nichrome coil, creating some amount of a heat energy. So that's why nichrome coil is going to heat up very quickly. But however, if you take copper, copper is not providing that kind of an obstacle or that kind of a resistance. If you are going to connect a copper wire into a circuit, that's why mainly that we are going to use copper as conducting wires, because the loss of electricity is very less. So these are my observations now. What were my observations? Nichrome coil has got heated very quickly and it is providing good amount of heat when you compared with the copper one, right? So the copper string is not getting heated. Actually, there is heat, but very less amount when you compared with the nichrome coil. Let's study first. In here, it's really important to study, not to write, right? Okay. So we'll study about more things related to electricity and how this heating effect is going to work with the resistance. Right. So let's head on to the classroom and we'll do our other things related to the lesson. Okay, my dear children. Now, within this activity, we'll be observing about the lighting effect provided by electric current. So, in order to identify the lighting effect of an electric current, I have several LEDs with me. These things are referred as light emitting diodes, type of a diode. Specialty here is that light is getting emitted when you connect these diodes or light emitting diodes with electricity. If you take, now I have two dry cells with me. You know that a simple torch bulb is going to light up by using just a single dry cell. However, if I'm going to use just a single dry cell and I'm going to connect it with the LED here, right? I'm going to connect it with the LED here. So you can see that there is no brightness in the LED. However, if I'm going to use two dry cells together like this, if I'm going to use two dry cells, in that case, the LED is going to light up. Specialty here is that in order to light up an LED, you need to provide more than 1.5 volts of potential difference. So in this kind of a dry cell, the potential difference is about 1.5, right? 1.5 volts. So two of them would create 3 volts. So when you are lighting up an LED, it's important to provide at least more than 1.5 volts. Means that definitely you will be needing more than one cell in order to light up an LED, right? So now let's connect. I have a switch, but I'm going to remove this thing because it's not needed actually. So I'm going to show you by connecting these things with these bulbs, and let's observe their colors. So first one, you observe that this has a blue color. Second one, let's see what's the color of this one. It has a colorless surface. We don't know the color. It's emitting a bright red color light. See, a good red color light. Okay, a red color light. Then let's go for the next one. It's emitting a green color light, my dear children. A green color light. See, we'll go for the next one then. So you can see here in some LEDs the color is already marked on their surface like this. So it's emitting once again a green color, and you can see that the outer structure has a green color as well. So if I'm going to turn this one off, compare it with the other one, this has a green color, this surface is blue in color. So blue color one is emitting a blue light, while the green color one is emitting a green color light. So this is another one, another LED. So let's connect it and we'll observe what's the color of it. So it's a white color, right? It's in white color. There's no distinct color in it. It's white in color, right? So these are the ones that we used in our normal flashlights. In our household LED bulbs, we use this kind of a light. Okay. So there are different types of lights which are getting emitted, right? There are different kinds of lights which are getting emitted according to the nature of the substance which used to create the LED, right? Most of the times we use the substance called silicon in creating LED, but however there are other substances like arsenic as well, right? So according to the substance that we use to make LED, right, the nature and the color which is getting emitted is going to change. So you will be learning about LED when you are moving on to grade 11, right? Further things related to LED. How does the color is going to change? What is their structure? Like that way, you'll be learning several things related to the LED in grade 11. However, up to now in grade 8, we have studied about the LED, and there are different colors, different materials are being used to create LED. So my dear children, this is the lighting effect of an LED, right? So specialty here in LED is that we need to provide at least 2 dry cells in order to light up an LED. And I'm going to take just one LED. We'll take the green one here. You know that when you take a simple torch bulb, it's going to light up even though when I'm going to change the terminals, right? There is no distinct terminals in a torch bulb. But however, if you take an LED, it has 2 distinctive terminals. If you take the structure of this LED and if you check it very carefully, you can observe one terminal of the LED. One terminal of this LED is somewhat longer than the other terminal. One terminal is somewhat longer. See, one terminal. You can observe that this is the shorter terminal. See, this terminal is shorter, somewhat shorter, right? And the other terminal is somewhat lengthier than the, right, shorter terminal. See, you can see it very clearly. This one is shorter and the other one is somewhat lengthier. If you observe all of these LEDs, all of these LEDs have the same nature, right? See, one is shorter and the other one is lengthier. See, So you know that there are two terminals when I'm going to use these things, right? One is shorter and the other one is somewhat lengthier, not that much but somewhat, right? So like that way, when you check each of these, you can observe that difference. So all the terminals that are lengthier, this one, this one, this one, all the ones which have a good length, or all the terminals which are lengthier are positive terminals. Those are positive terminals. Shorter ones are the negative terminals. So I can show it to you. So this is the lengthier terminal. I'll use a different one so that you can observe it very clearly. So this is the lengthier terminal. See this one, the lengthier terminal. This one is the shorter terminal. So when I'm going to connect the lengthier terminal with the positive here, you can observe that it has a red color, and the negative here, the bulb is going to light up, right? So what happens if I'm going to interchange the two terminals? Going to interchange now. See, lengthier one. See, lengthier one with the black color negative and the shorter one with the positive. See, no difference at all. Once again, if I'm going to interchange, the light bulb or the LED should light up. See, it's lighting up. So my dear children, when you are connecting these LED, there is a speciality. Speciality is that there are two distinctive terminals as positive and negative. So always the lengthier terminal is the positive one and the shorter terminal is the negative terminal in each and every LED. That's the standard way of denoting an LED, right? Usually when they are being published to the commercial market, one terminal is somewhat shorter than the other one, right? So that shorter terminal is the negative terminal and the lengthier one is the positive one, right? So let's head on to the classroom once again and we'll discuss further things related to our lesson, right, my dear children? Now within this activity, we'll be identifying the magnetic effect given out by the electric current, okay? So I have prepared a setup, a simple setup with me. There are two iron nails here and here, right? These two iron nails are connected with crocodile clips, which runs through the switch and comes back to the positive terminal, which goes through here and comes back once again to the other iron nail. So you know that when I'm going to turn on the switch, an electric current is going to flow towards that direction and which is going to come back to the negative terminal, starting from the positive terminal. So you know that if you take a compass, now there is a compass, this is a compass, you know that this is a compass. If you take a compass, my dear children, a specialty in compass is that compasses are made up with freely rotatable magnets. So there is a magnet which is placed below the copper wire that runs through from here to here. There is a magnet in here. How can I say it is as a magnet? Because it is a compass. You know that compasses are simple magnets, right? So I have taken another magnet here in order to show that there is no deflection in this one, but there is a deflection in that one when I'm going to turn on the switch, right? So this is some kind of a modified activity so that you can get a sound or wonderful observation. So I have used two compasses here. So what I'm going to do is now, first of all, I'm going to show you that this is the north direction towards that, and in the second compass also, the north direction is that, right? Both the compasses are now showing north direction. Now I'm going to turn on the switch and let's see what happens with the compass needle of this one, which is at below the copper wire. So let's see what's going to happen. So once again, I am going to turn on the switch. See, it is getting aligned now. Now the switch is in off stage, right? Switch is off. It is getting aligned with the same direction as the second compass here. This is the first compass below the copper wire. Turn on. Compass needle is going to turn to that direction, but however, the second compass needle is remained in the same position. You can observe it very clearly. This haven't got changed, but this one has got changed. Means that when current is flowing towards that direction, some kind of a energy is pulling this magnetic needle towards that direction. So you know that magnets are getting influenced with the magnetic properties or magnetism or magnetic field. Even these magnets are, or even these compasses are turning towards north and south direction because of the geomagnetism. So when I'm going to turn on the switch, some kind of a magnetic field is getting generated on the copper wire so that the needle of the compass can turn to a different direction. It's because of the magnetic field created by the copper wire. That's why it is getting influenced. Because the compass needle is also a magnet, and when current is flowing through the copper wire, a magnetic field is getting generated. So the two magnets are getting interacted each other to change the direction of the compass needle. Once again, I'm going to show you by turning on the switch. See, this one changes, but this one doesn't. Now I'm going to show you some kind of a different observation. I'm going to keep both the compasses near each other like this, but at a somewhat different. Okay, let's keep this thing for a while so that they would align in the same direction. Yes. Okay, my dear children, now I have placed the second compass also near or below the copper wire. Now let's turn on the switch. Now once again you can observe that both the compasses are showing the same direction. Okay, now once again I am going to turn on the switch and let's see whether there is a deflection in both the compasses or not. See, both the compasses are going to deflect. Now by keeping this compass in the same way, I am going to take the other compass away from the copper wire. See what has happened. Once again, it would align in the north direction. However, this one is again still at the same position. So when I am going to disconnect it, it runs back to the original position. So this concludes that a magnetic field is generated by the copper wire when current is going to flow through it. So by this activity, we can finally conclude when there is an electric current, automatically a magnetic effect is getting generated around the conductor, right? Okay then, so let's head on to the classroom once again and we'll discuss further things related with our lesson. So my dear children, in this activity we'll be studying about the magnetic effect given out by electric current. Especially, we are finding out what are the factors that's going to affect for the magnetic effect, right? So I mean like what kind of factors that can be changed in order to get more amount of magnetism, or else if you want to reduce magnetic effect which is getting created, what kind of thing that can be done. So we'll be needing these materials first. Okay, we'll be needing a copper coil. So here I have with me a copper coil, right? So like this, we'll be needing a copper coil, and this copper coil is wrapped around an iron nail. As you can see here, it's wrapped around an iron nail very well. Then after that, a switch, and some connecting wires, some pins, file clips and pins. Then I have an ammeter with me, right? Then these are several connecting wires over here. And to power up the circuit, I have dry cells. So first of all, what we are going to do is we're going to connect this system to an electric cell by using these instruments. So I'm going to connect the switch here, then our ammeter, then right now I'm going to connect the coil wrapped around the iron nail like this for these two terminals. Now my circuit is completed. So what I have done here is the ammeter comes to the positive terminal, goes like this, connects with the iron nail wrapped around the coil, and comes here to the switch and goes back to the negative terminal in here. Okay, so this is my circuit. Now what I'm going to do is I'm going to take the pins. Now what I'm going to do here is I'm going to turn on the switch and let's see what's going to happen. So you can see there is a clear deflection in the ammeter. It's getting attracted towards the, see, 1 2 3, there are 3 pins which are getting attracted towards the iron nail. So 3 pins are getting attracted to the iron nail when I'm going to supply one dry cell. Okay, right. Now I'm going to disconnect my circuit once again. Right, I'm going to disconnect my circuit. Now in the second step we need to remove the iron nail and try it with only from the coil, but however it's difficult to remove and re-enter these things to the system. So what I'm going to do is I'm going to repeat the fourth step in here. I'm going to insert 2 dry cells now, and to provide a good current to the circuit, right? So earlier it was only from one dry cell like this, from one dry cell. So we turned on the switch and you could observe that 3 of the iron nails are getting, 3 of the pins are getting attracted. See, there is like 3. Now at this time there is 4, right? So there is a clear deflection in the ammeter reading as well. So ammeter reading now is at 0.4. See, 0.4. 0.4 is the answer for the ammeter reading, and there are 4 pins which are getting attracted. So I'm going to cut the current now, right? So 0.4 and 4 pins. Now I'm going to insert the second dry cell. So it would make this practical rather more easy, right? And going to insert it like this. So remember children, 0.4, 4 pins. Okay. Now let's see what is going to happen here. So at this time you can see that now it's way more greater than 0.6 of amperes, right? the ammeter reading is greater than 0.6. However, we'll take that one as 0.6 amperes, right? So if I want to change the, if I want to get a accurate value, I need to change the scale to 3 here. By that I can get a value, right? So let's see how much is it. So it deflects greater than 1 and it's greater than 1.4. Yes, 1.4, but it is keep getting reduced from time to time because of the effect given here. So I'll name it as 1 here. We'll take it as 1, right? It's more closer to 1. Actually it's 1.2 now, so it's more closer to 1, right? So we'll round off this thing and we'll take it as 1. Okay, so now when I'm connecting two dry cells, 1 ampere of a current is obtained, and let's see how many pins are getting attracted at this time, right? So you can see here there's a file clip, and 1 2 3 4 5 6 pins are getting attracted with a file clip. Now altogether there are 7 clips or 7 pins which are getting attracted. So when I'm using two dry cells, 7 pins, and the ammeter reading is at 1 amperes, somewhat slightly greater than 1, but however we'll round off and take it as 1 amperes. So in the earlier case, 0.4 and 4 pins. This time 1 ampere, 7 pins. Okay, 1 ampere, 7 pins. Right, then I'm going to disconnect this thing now. Okay, I'm going to disconnect. Now let's go for the other steps. So as you can see here, when I'm connecting two dry cells, my dear children, I'm providing a greater current. You can see it by using the ammeter reading. So ammeter reading runs to 1 ampere when I'm using two dry cells. In the earlier, it was around 0.4, right? So in the first case, when the electric current is only 0.4, only 4 pins got attracted towards my temporary magnet. However, when I'm going to increase the number of dry cells to increase the current of from 0.4 to 1 ampere, I could attract 7 pins. Means that my magnetism has got increased during the process of increasing dry cells or increase in current. So when I'm going to increase the current, you can clearly see that the magnetism of the electromagnet or the magnetic effect given out by this circuit is going to increase. So we can say that when electric current provided to a system is greater magnetic field can be observed. Now let's go for the other cases as well. So now I'm going to remove this, right? I'm going to remove this and I'm going to take the iron nail out. Okay, like this. Let's take out the iron nail. Right, so we have removed the iron nail now. Now what I'm going to do is, once again I'm going to supply electricity. I'm going to keep both the dry cells. Once again I'm going to provide electricity to this coil by removing that iron nail. Right, here we go then. Once again you can observe that the current is at 1 ampere range. Now let's see whether these things are getting attracted to the coil. Right, so here you can see just a 1 pin is getting attracted. Just a 1 pin. But however, when I'm going to insert the, you can remember that when I'm inserting that iron nail, right, 7 got attracted, but however at this time only 1 got attracted. Means that from this activity we can say that when I'm going to remove the iron nail in the system, or when I'm going to remove the soft iron bar, it's going to affect the magnetism, right? And when the magnetism is going to reduce when there is no soft iron core within the coil, right? Then the third step. In the third step, what I'm going to do is I'm going to reduce the number of turns in the coil. So in order to reduce the number of turns in the coil, so I'm going to take it like this. I'm going to keep, now I'm going to remove several number of turns. So in removing number of turns, what I'm going to do is I'm going to remove a piece of copper coil in here. So I'm going to take this and I'm going to remove it. So let's remove. Right. So you know that every conductor, right, every copper coil, it has some kind of a covering, right? So I have removed a piece, you can see it very clearly. Okay, so every coil has a some insulation around the coil. So I'm going to insert the iron nail as well, right? So let's insert the iron nail. So this one contains this one also contains some kind of a layer in here. So we need to scratch it up. Okay, so to scratch it, once again I'll use the same instrument. So let's scratch this thing up. So we need to scratch it very well in order to remove that coating. There's a plastic kind of a coating over here. You have to remove it, otherwise the electricity will not be conducted through it. So we did this experiment when I was doing the magnets lesson also. I told you that in a certain or in every kind of a coil, there is an insulation around it, like a special kind of a coating. So we need to remove it before connecting to a circuit. So here you can see the color change very well, right? Now let's connect it and we'll see what's going to happen. So I'm connecting it. Now you could remember at the earlier case, 7 pins got attracted. Now let's turn on. Yes, once again you can see that the ammeter reading is at 1 ampere. So let's see how many pins are getting attracted once again, right? So let's see how many pins are getting attracted, right? So 1, 2, 3 and 4. You can see that 4 pins are getting attracted towards the iron nail at this time. But however, you can see that the ampere range is at 1, around 1. Okay, I have removed a piece of copper string. See in here you can observe the piece which I have removed. I have removed a certain piece of copper coil from the initial one. So when I'm going to remove a piece of copper coil, you can observe that the number of turns within the coil is going to reduce. So I'm going to disconnect the circuit. When I'm going to reduce the number of turns within the coil, you could see that only 4, see only 4, 1, 2, 3 and 4. Only 4 of the pins are getting attracted towards the iron nail. So by that way we can say that when decrease in the length of the conductor, when decrease in the length of the coil, when decrease in the number of turns within the coil, we can say that the magnetic field or the magnetism generated within the circuit is also going to reduce. So that's why less number of only 4 pins are getting attracted towards the iron nail. So by that way we can say that when reducing the number of turns within the coil, the magnetism which is getting generated is also going to deplete, right? Less amount of magnetic field is getting generated when I'm going to use less number of turns around the iron nail, right? So these are the things that we need to consider, my dear children, when we are considering about the magnetic effect. First and foremost, the current which is getting provided or current provided to the system is going to change the magnetic effect. The presence of an iron bar or else a presence of an iron core is going to affect for the magnetism. Then the third one, the number of turns or the length of the conductor, and by increasing the number of cells I have changed the current in the system, and the current is also going to affect for the magnetic effect. So there are 4 factors, right? So these are the factors that we have studied in here under the magnetic field. By changing these factors we can change the magnetic effect given out by the electric current. So there are 4 main factors. Once again, presence of an iron core, length of the conductor or length of the coil, then the current given to the circuit, magnitude of the current given to the circuit, then finally, right, the number of the presence of a iron core, then second one, coil, the length of the coil or the length of the conductor, then after that current given to the circuit, then finally you can say that when changing these factors, right, we can change the magnetic effect. So let's head on to the classroom once again and let's see what are our observations and conclusions from the activity. So my dear children, within this activity we will be investigating the chemical effect given out by electric current. Means that by providing electric current we can result a chemical reaction or else a chemical change, right? So to do this activity, first of all we'll be needing like 150 milliliters of 150 to 200 milliliters of acidified water. Acidified water means, children, now I have added water, and for that water few drops of, not a heavy amount but few drops of acids, right, 2-3 drops of acids. Then after that I have a dry cell with me. So here I have used a 9-volt dry cell in order to provide good steady current flow. Then 2 carbon rods to provide electricity. So carbon is a good conductor of electricity, right? Carbon is a good conductor of electricity. Even though carbon is not a metal, it's going to conduct electricity very well. Actually, these carbon rods are made up with graphite. Graphite is made up with carbon. So these are graphite rods. Graphite is a good conductor of electricity even though it is a non-metal. So what I'm going to do here is, now I'm going to take the dry cell. First of all, we'll connect the 2 terminals to here, number 1 and number 2. Then steadily I'm going to insert the 2 terminals. Remember, when you are inserting these terminals, make sure that they do not touch each other. If they touch each other, then you won't be able to get the necessary outcomes. So here we go then. Then after that I'm going to connect the second terminal. Then, so here we go then. So as soon as I'm going to insert the carbon rod, you can see gas bubbles which are getting formed within the system. See? So I'm going to remove it then. So now I have removed both the carbon rods. See, there are no gas bubbles. Now let's insert once again and see what's going to happen. See, as soon as I'm inserting the two terminals, you can observe gas bubbles which are forming inside the system. So it's very clear to us that when I'm providing electricity to the circuit, actually to the solution, to this acidified water, there's a chemical reaction or else a chemical change which is going to occur. How can I say that? Because the gas bubbles are getting formed here. New substances are getting created from the earlier substances. So we can say that a chemical reaction has happened within the acidified water when current is passing through it. Now once again, let's head on to the classroom, my dear children. We'll write down our observations and conclusions. So my dear children, within this activity, here also we are investigating about the chemical effect given out by the electric current. But however, what I'm going to do in this time is, I'm going to use that electrolysis process in order to plate copper on the spoon that I have in here, right? So first of all, I have a copper plate with me. I have scratched it by using a sandpaper. Then I have a copper sulfate solution. So if I'm going to plate copper on a certain surface, I have to use a sulfate or else a solution of copper. So here in this time we have used copper sulfate solution. Okay. So this is my positive terminal now. As the positive terminal, I have to use this metal plate which is copper. So I'm going to insert this into the system. Then let's connect it with the positive terminal of the dry cell, the red color one. So my dear children, the other case is that it's important to not to touch with the negative terminal, right? Negative terminal is now my spoon in here. So I'm going to insert. So you can see there are no any other metals which are plated on the spoon. You can see it very clearly, right? There's nothing in here. So I'm going to insert it and make sure that they do not come in contact with each other. Then we'll connect it with the negative terminal of the dry cell here. Right. So we have to wait for a while. Now if you check the spoon in here, you can see that there are gas bubbles which is getting created. So we'll wait for somewhat time and let's see what's going to happen. Right, my dear children, now let's see what has happened here. So as you can see here, it's very clear to us that there is a copper color, like brownish color substance on the spoon. See? So there is a brownish color substance, right? I can wipe it off by using, right? a tissue paper, I'm going to wipe it off. See? So this substance is copper, right? So copper is getting plated on the spoon. Once again, I'm going now. Let's remove the stain like this. And once again, I'm going to show it to you. So here you can observe it very clearly. See? So let's wipe it off. So I have wiped it off. So let's insert it once again. Right, so I'm going to take it off. And you can clearly observe once again, there is copper around the spoon. See? Right, so I can remove it by using this. See? So there is a clear stain. You can see it very clearly. There are two different colors. See? Right. So here we can finally conclude that within this system, when I'm going to provide electricity for the copper sulfate solution, for the copper plate over here at the positive terminal, then on the negative terminal we can plate copper, right? So always the object which the metal needed to be plated, it should be in the negative terminal, while as the positive terminal you have to use a metal rod or else a metal piece that we are going to plate should be on the positive terminal. Okay, so if you are plating gold, then we have to take a piece of gold as the positive terminal and the negative terminal whatever a necklace or else a jewelry, right? So this is how the plating process is being conducted even in the industrial level. So it's really simple, right? So this method is referred as electroplating. Here also we provide electricity in order to get or in order to give out a chemical effect, right? So let's head over to the classroom once again and write down our observations and conclusions from the activity.